Yeah, hello everybody, and I'm happy that you are joining Cooling United of Danfoss, and thanks for the nice introduction to my talk. The title you have already heard, Constant Change of Cooling, and it deals with decarbonization, so global warming, and some environmental considerations regarding sustainability. And when I studied mechanical engineering 30 years ago, and focused on refrigeration, a thermodynamic professor said to me, it's not a good topic to study because nothing will change. And now we experienced a lot of changes, especially in the last years. And I'm going to tell you from our view what we experience and what we see and what we have as an outlook for the future. So cooling is actually present in very different areas of our lives. It is there from the beginning of the life all the way to the end. And in capacity and temperature ranges, it's covering more or less anything from refrigeration in industrial processes, so big applications, commercial refrigeration, which is supermarkets, and then also air conditioning, comfort cooling, all the way to indoor air quality in the end. And then also, of course, increasingly heat pumps. And then we just have to keep in mind that about 20% of the overall electric capacity or power produced is actually used for refrigeration and air conditioning. So that is 1/5 of the entire electricity consumption of the world. So it's a significant number we're talking about there. And when it comes to global warming, climate changes, then we actually have two contributions from refrigeration, the refrigeration or cooling systems to the global warming impact. And there is the direct contribution and there is an indirect contribution. The direct contribution is related to the refrigerant themselves, which have a global warming potential. And when they leak out into the atmosphere, they contribute to global warming or climate change. And the second portion is due to the energy consumption of the system. So when energy is produced, CO2 is emitted to the atmosphere, and this CO2 is then also contributing to global warming. So in total, it is direct plus indirect emissions, that contributes to the greenhouse effect of cooling systems in general. And then we could ask ourselves, well, how do we actually make sure that we have cooling? And in the very old day, a more or less environmental friendly way was to cut ice from big lakes and transport it all the way through, especially in the US, from the north to the south, to make sure there was cold materials, ice in this case, available in summer. Obviously, this is not a process that is suitable today, maybe limited extent, but in generally not. And so we all know all these different processes that actually make sure that cooling is generated. Many of you probably know many of these processes, and I don't really want to go into detail. They all have pros and cons. But today, most of the systems used are the Carnot process, or also called reverse Rankine cycle. And this process is the normal refrigeration process we know, with a compression, a condensation to the heat sink, an expansion, and then the evaporation at the heat source. So this is the part where it's getting cold, and then it goes back to the compressor. And there, obviously, different applications are used. And this is now shown on the right side of this slide. We have different applications from mobile air conditioning, commercial refrigeration, and then all the way down to domestic refrigerators. And what you can see here is a plot with the direct emissions. So this is the emissions related to refrigerant leakage, and the indirect emissions, which were the emissions related to energy consumptions of the system. So global warming of mobile air conditioning is in the very top of the chart, and this means there is a big direct contribution, a lot of refrigerant leakage, which means refrigerant goes to the atmosphere in case of accidents or leakage of the system. And therefore, there's already a regulation in place which basically says that the refrigerant in these systems must have a GWP under the value of 150. And if you look down at the list coming to commercial refrigeration and then unitary air conditioning, these systems are addressed presently by legislators because of the direct contribution, which is considered to be too big. And domestic refrigerators with hydrocarbons have, for example, only a contribution through the energy consumption. So this means that when it comes to looking at different technologies or different refrigerants, I should say, the leaky systems are the ones that are addressed first by the legislators. So where are we standing today? It's almost 200 years of refrigerants that we have been using. It started with natural refrigerants because there was nothing else available. Then in the 1930s, the CFCs were invented. Then a little bit later, after discovering their impact on the ozone layer, the HCFCs came up, which still had a contribution to the depletion of the ozone layer, but it was smaller. And then due to this contribution regarding the ozone, because of the chlorine in the molecule, we use today HFCs, which have no chlorine and which have, I now say, only a global warming potential, but no ozone depletion potential. And due to the global warming potential of these refrigerants, now there is a trend to go to low GWP refrigerants, or even again back to natural fluids, namely hydrocarbons, ammonia, CO2. So there is basically the forced transition of refrigerants ongoing, and safety, of course, is a main topic that needs to be kept in mind. It's a qualifying parameter, you can say. But of course, energy efficiency is also very important, because the direct contribution, if the refrigerant has none, then everything gets the indirect contribution. And this means energy consumption is key, and this is energy efficiency. And then, of course, some regulator initiatives, they basically drive the technology development and ask for new solutions. So this is basically the cycle of 200 years of refrigerants. And then you can ask, are there any options? Well, I brought this periodic table of elements. I know some people don't like it because they didn't like chemistry at school. The good thing, though, is this diagram has not changed in the last, I would say, as long as the Earth is there or people exist. So we can assume it just stays like this. And then if you want to build refrigeration molecules, then only these 8 elements are suitable to do so. There is maybe an exception with iodine down at the end below bromide, sorry. But basically it's just these 8 ones that are suitable. And if we take over to the left side of this diagram, so combining H and C, then we have hydrocarbons, and they are obviously very flammable. And if we go down in this diagram, then things get more toxic. And normally you don't want flammable refrigerants, and you normally don't want toxic refrigerants, but it will be a compromise in future between global warming, flammability, which is basically stability, and then also, of course, additional safety measures to make sure that nothing happens when you operate the system. So we use something that we call a cooling sustainable triangle, and it's basically making the best possible compromise between cost, which is not only first cost, but also then operational cost. So this is related to energy consumption, environment, global warming potential of refrigerants, and energy efficiency. So that is the direct and indirect contribution. And then safety, which can be addressed in the case of, for example, flammability by education and certification and training. This is the key to make it possible to use these fluids in a safe way. I said before that due to the global warming potential of HFCs, there are different phase down scenarios globally, which are basically asking the refrigeration industry to live without HFCs in certain steps. And there is, everybody knows probably the different regulations in the different countries. The EU directive, for example, the red line, is asking for a reduction by almost 80%, sorry, until the year 2030. And the other curves you can see on this chart. And this, of course, has an impact on the price development, on the availability of refrigerants, and then also on logistics. And I guess most of us followed this in the different dialogues in the media. So this is a chart showing some initiatives on a global plan. When I talked about the F-gas regulation in Europe, then this is Europe. But let's start in the West, in the US. So there are several states that have their own individual measures to bring down refrigerants with a high GWP. And this is then again some HFCs, especially in commercial refrigeration. Europe we talked about. Then if you come to India, they have also initiatives over the next many years, 20 years, we have plotted here, where it comes to the reduction of refrigerants, but also to the reduction of the energy demand of refrigeration systems by significantly big numbers. Same approach more or less in China, where low GWP refrigerants are favored, and there also energy efficiency is in focus, and energy efficient systems are promoted to get a bigger market share in the refrigeration market. And then the last example on this slide is Japan, where there are also phased down legislative initiatives on GWPs with specific targets starting from 2014 already. So other innovative impacts on cooling, and cooling is used here as a word because we are the Danfoss cooling segment. It's also addressing refrigeration. There is, of course, the driver climate change, which I call decarbonization in the title. So it's about refrigerants, it's about system efficiency. And then one point that is getting very important also is waste recovery. So it's more or less running a heat pump, so using also the warm side. And this is, from an efficiency point of view, a really interesting solution, and it's taking more and more part in the market. Digitalization is, of course, something we all realize. I mean, I'm a living example taking part in this event, in this case, in a digital way, and you're all digital as well. So using basically this, what is called here data collection, data sharing, and this is what it's all about. It's about also preventive maintenance possibilities. And then another interesting point is also peak shaving and energy storage. I mean, we all know that when wind and solar power is used and sun is shining and wind is blowing, then there is too much power. And on the other hand, it can also be the other way around. And then refrigeration industry is actually already providing a very big storage potential because of the infrastructure that is already existing. And so energy storage and peak shaving will get more important in the future. Cold chain, food supply, I guess that's something we all know as well. There is actually a change going on from normal shopping to online shopping. There is impacts on transport and then also on the logistics and also on the way how food is actually produced and distributed, also to avoid food waste. So this is also something that will definitely drive, let's say, the future of refrigeration or cooling industry. Electrification is another topic. I mean, if you think about the amount of heat pumps that were installed in the last years, then heat pumps are on the way to replace oil and gas as the primary heat source, as the primary energy source for heating, space heating. And then also other systems that were normally built as open type systems, they are also getting more hermetic, or saying hermetic. So they will be welded or screwed together to avoid any refrigerant leakage. And then more and more people are moving to cities. So urbanization is one of the topics that is also getting very important. So we're talking here about not only air conditioning or comfort cooling, but it is actually indoor air quality. I mean, the reason why we're all sitting at home, we all know. And this is definitely about indoor air quality and about having the possibility to also kill bacteria and viruses that are flying around in the air around us as aerosols. Then, of course, data centers and server rooms are increasing. There is a big potential for energy saving as well, if we do things in a slightly different way. And then, of course, when people are closer together, logistics and transport move also into the focus. So this is what we see as the main drivers for the future that will keep cooling changing. And to sum it up a little bit, I took the title again, The Constant Change of Cooling. And I think we all understand that it needs a very holistic approach to make sure that we get a minimal impact on the global warming. So this is the decarbonization point, energy consumption or energy efficiency maximum, and then the refrigerant impact. It's about leakage, it's about containment, it's about the GWP of the refrigerant itself. And then we also introduce new processes and materials from adjacent industries. I mean, first, all this electrification is something that hasn't been used in refrigeration before very much. And then, of course, from, for example, car industries or other industries, there are components designed and manufactured in large number, which have sometimes advantages to these materials and technologies used in refrigeration. And they will help us in cooling to make things more sustainable, but probably also to get advantages on the cost side, which doesn't necessarily mean that things get cheaper. And then last but not least, I just encourage all of us, even if we've been in the industry for a long time, let's constantly react on any changes of boundary conditions. I mean, this is, for example, if there are initiatives to focus on climate change, or if there are initiatives, now I think about energy consumption, CO2 emissions, or if there are initiatives of certain parties to go after certain refrigerants, then we just need to keep in mind what is the impact on cooling as an industry. And I think throughout the next presentations in the coming days or hours, actually, I hope that these things get a little bit more explained, or they will get more explained in detail. And I look forward to further discussions, and I hope that we as Danfoss always take care of that. We are on the top of what needs to be done to stay around with a safe and healthy future. And with that, I thank you very much for your attention, and I hope you enjoy the rest of the conference.